Welcome to Taking Up Space, where I take up space on the newscast by talking about space. B. Douglas Edmonds is an assistant professor of physics at Penn State Hazleton who won the 2018 Buchalter Cosmology Prize. His work with his colleagues on modified dark matter took second place. More on that in a moment, but first, the second grade. That's where Edmonds won an art award for his cityscape he created that his art teachers described as mathematical. He eventually went to college to study fine arts, but he also grew up in awe of the night sky.
When I was young, we used to go outside at night. My father was pretty patient with these type things, and we would go out and just lay on the ground and stare at the sky and just ask questions about it. He was actually uneducated and so had no idea what was actually going on in space, but was just fascinated by the whole thing. So we would ask a lot of questions and not necessarily have any answers. And growing up, I would consistently try to answer these questions. We would just say, like, I wonder if this is working or that is working. And so I think that act of questioning maybe was very much a trait of physics that I grew up with, never knowing that it was actually physics.
During his study of fine arts, he took a bunch of other courses, including physics, and well, the rest is space-time, or history. Trying to tackle some of physics' biggest issues requires a lot of questions.
My wife will attest, she gets very frustrated. Once recently, we were driving on a trip. She woke up and realized we were going the wrong direction, and we had been traveling that way for about 3 hours. And so we had to turn around. It added 6 hours to our total trip.
Okay.
She
What
was
were you thinking about?
I was thinking a lot about the structure of space-time and how things are, organized and just that sort of thing. And my mind was just wandering.
Edmonds' mind found its way to dark matter and dark energy. What is dark matter and dark energy, you ask? Well, let me tell you. I'm kidding. Let Edmonds tell you. When
we look at galaxies, we see the motion of stars, and there seems to be something that we're not seeing that's causing those stars to move in a certain way. So it's a gravitational attraction to those stars, and that's dark matter. So we don't see it. That's how we infer that mass is there, that dark matter mass. So it's dark matter is some sort of matter that's causing gravitational effects on galaxies and galaxy clusters. Dark energy is sort of the opposite issue. Our universe is expanding, which we've known. If we think about the Big Bang, the universe starts expanding, and you might expect it to expand out and maybe be slowing down as it's expanding, or maybe even be recontracting. But actually what we find in observations since the mid-90s, since the Hubble Space Telescope went up, the expansion is actually accelerating. And so there's some energy that's causing it to expand faster and faster and faster at a faster rate, and we call that dark energy.
Modified dark matter is going to blow your mind, so get ready to really concentrate here. Do some mental stretches. It's going to be worth it.
What makes modified dark matter differ from the other models, what makes it unique from the other models, is that it interacts non-locally. And the way it's distributed in space seems to depend on non-local interactions with both regular matter, ordinary matter, and dark energy. And so that's what makes that particular model unique in all the dark matter models.
When you say non-local, what are you talking about?
Non-local interactions would mean somehow that two things interact with each other without coming into any contact, without any contact with each other through any field or anything like that. They would just be completely separated and yet influencing each other. We assume when we say there are two different places that they're somehow separate from each other. But that's our idea of locality, that to be local it has to be here, and if it's over there it can't be local. But we're not sure that those ideas of locality are actually correct in certain situations. And quantum mechanics has been one of the places where we find strange behaviors. And so, for example, entanglement, when we mess with a particle here and the other particle reacts to it, there's some question about what we mean by the space between. And so it's a question, and when we say non-locality, we definitely don't fully understand non-locality or how to work with it. It's in the mathematics, as you said. We can put it in the mathematics. Even the mathematics of non-local physics is very hard to deal with. But it really starts to address that question of what it actually means to be local. And when I mentioned before, when I think about the structure of space-time, these are some of the questions that occur to me. Am I really here and that space over there is distinct from me? Or is there some sense in which there's no distinction between me and that space? And so what do we know? What is this idea of locality and non-locality?
Okay, you may want to rewind that and watch it a few more times, or check out this story on SSPTV.com and just watch it over and over. Now, these big questions have a way of bringing us all together.
I think, the question of understanding our universe, or even just knowing a little bit about it, whether you understand it or not, is definitely uniting. The interest in astronomy is universal. It's worldwide. And that's because I think we've all looked around and said, I wonder why this is happening. I do think that kids grow up natural physicists and then sort of get moved out of it. Kids always have this natural questioning, and then over time they lose that, or they tend to lose it. And I definitely had a time where I had lost that ability to ask questions. And I think part of it is because we get afraid of being wrong, as if there's some right answer. And the truth is, we don't know the answers to most of the things, and questioning is more important than that anyway.
Now, whenever we sign off on one of our stories, I'll say, like, I'm Ken Kara at Penn State Hazleton. If I'm wrong, please correct me, but I'm at Penn State Hazleton. There's a possibility, the space between me, I'm still back at the office as well.
That's right. You might be in both places at once, or they wouldn't be two separate places.
Okay, Edmonds and I talked for a while discussing how the artist inside of him visualizes dark matter and energy and other topics. To see that bonus content, check out the SSPTV News Facebook page. I'm Ken Kara, and remember, space is cool.